Our first presenter is Dr. Jeanette Boudreau. Jeanette is a translational immunologist studying new treatments for pancreatic cancer. Her laboratory is focused on a subset of immune cells called natural killer cells and the genes that control them. Dr. Boudreau's research laboratory collaborates with clinicians, basic scientists, and geneticists to create, evaluate, and improve precision immunotherapies for cancer. Dr. Boudreau received her PhD from McMaster University in Hamilton, Ontario, and completed postdoctoral training at Memorial Sloan Kettering Cancer Center from 2011 to 2016. Dr. Boudreau is the Dalhousie Medical Research Foundation's Cameron Cancer Scientist and an assistant professor of immunology and cancer at Dalhousie University. So without further ado, we'll pass it on to Dr. Boudreau.
All right. Well, feel free to reach out in the chat or interrupt me at at points throughout the chat. I've sort of just put together a brief introductory presentation to kind of walk through what precision medicine is. And then Cassadie, who will speak after me, is going to walk you through some of the logistics for actually putting this into action for you. But as Kate said, I am a scientist, I'm a researcher, and I work at Dalhousie University up here in beautiful Halifax. And my lab is really focused on really moving the needle forward for patients with pancreatic cancers and other hard to treat cancers. And I think we're learning a lot of lessons by, sort of zooming out and thinking about cancer as a disease, and then, zooming into some of the more specific things that we're going to talk about today. So my slides aren't advancing. So I thought we would just sort of start by reminding ourselves what cancer is. And cancer is a disease that, of course, can affect many, many tissues in the body. It's different wherever it is, but it also has some absolute commonalities. And in thinking about what cancer is and how it comes to exist, we can sort of start to think about how to treat it more precisely. And that's going to lead us right into precision medicine. So, of course, every cell, every tissue in the body needs to fix itself. It's not perfect, and cells get old faster than our bodies do in general. And a way that our bodies maintain themselves is to just refresh the cells that are in the tissue. So it's not that you're regenerating a new pancreas or a new liver every day or whatever, but we do know that our tissues turn over. So old cells get replaced with new cells, they divide, and it provides an opportunity to kind of rejuvenate, for lack of a better word. So we've got somewhere between 70 and 100 trillion cells in our bodies, and those cells turn over at different rates depending on where they are and what their role is. In the pancreas, the epithelial cells, which are the most common cells that can give rise to pancreatic cancer, they turn over every 2 to 6 days. So there's this constant refreshing that's happening in the cells. And so what happens is one cell that's healthy acts as kind of a stem cell. It's not a stem cell in the way you think about them as research, but sort of an early version of the cell that can then divide. It copies all of its DNA and it makes 2 daughter cells that are copies of that cell. And then the cell can continue to exist and perform all the functions of a normal pancreas epithelial cell. And so really what cancer is when that process falls off the rails. So our cells have to rejuvenate themselves. They have to be balancing and copying DNA all the time. And sometimes they need to do it fast, and sometimes they can slow down. So you can imagine that there might be an opportunity where a cell sustains some injury or is exposed to a toxin, and we need to turn over the cells faster, or other times when things are going great and the body is healthy and we don't need to go that fast. And so there's all these signals within the cell that say it's time to grow, it's time to slow, we need more, we need less. And all cancer is the event that happens that leads these cells to ignore the stop signals or to start making their own autonomous go signals. And when we start getting too many cells, that's what becomes a tumor and, of course, proceeds to cancer. And so that's all cancer is. It's just an uncontrolled proliferation of cells that are starting to interrupt normal function, starting to suck up nutrients that we would normally need to keep healthy cells going. And as the tumor progresses and gets bigger, that starts to interrupt normal function. So over on the left here, these are just healthy cells undergoing that normal steady state. And over on the right, this is a tumor that's starting to use up too many resources and grow too much. And so the way that classical cancer therapy works, and especially in terms of chemo and radiation, is to just interfere with the growth of cells. So most chemotherapeutic drugs work by introducing some sort of toxin into DNA. So as a cell is trying to make more and more DNA, it gets tricked into picking up something that tells the cell to die. It sort of creates a fatal flaw in that cell. And so all the rapidly dividing cells in the body are induced to die. So of course that includes the cancer cells, but that also includes lots of other healthy cells that are just undergoing this normal turnover. And that's why a lot of chemotherapies and radiations are associated with these really terrible side effects, right? So what we want to be able to do is more precisely target these cancer cells while leaving all the other healthy cells alone, so we don't have the side effects. And so, I talk about DNA mutations as though it's, one thing that happens to one cell on one bad day, but that's not actually what happens, because we've got all kinds of fail-safes. And so really, as these cells are growing and developing and maybe becoming cancerous, there's a lot of checkpoints that have to, be ignored before a tumor actually develops. So there's, these signals that say, wait, something's not going on. And it's really only when the tumor starts to ignore those signals and say, nah, we're doing okay, that a cancer can actually start to happen. So let's talk numbers. Let's see how quickly this happens. They can lose their ability to detect their own uncontrolled growth. But that actually requires a series of mutations to happen. It's not just one gene that breaks and then leads to a tumor. You actually need a bunch of these to happen. And so it happens over time. You can imagine that something that leads to a mutation when you're younger, maybe you've taken up smoking or something terrible that leads to some mutations. Maybe those mutations aren't enough for cancer, but they're enough to increase that basal threshold. And you start ticking up, 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 up. And over time, eventually you just tilt over that threshold. Now, some people unfortunately have what we call a germline mutation in certain genes that can be associated. So these are things I'm sure you've heard of, like BRCA genes that increase your level of risk. Which essentially just means that instead of starting at the bottom with sort of no mutations, maybe you start with one or two mutations and you're that many steps closer to being able to develop a tumor. And so this is why you sometimes see cancers running in families. Sometimes you'll see mutations in genes that are associated with more than one type of cancer because they're really just associated with these fundamental functions of cells to turn themselves over. And you'll see these families where there's lots of cancer in it, but it's not always the same kinds of cancer. And other times you'll see mutations that are more tissue specific. And so you'll see a high frequency of specific types of cancers. Colorectal, for example, is a big one out here in Atlantic Canada. So all this is to say is that you can have mutations that both exist in normal healthy cells. You're born with them. You got them from one of your parents, and some of your siblings and cousins probably have them too. But you can also have mutations that happen in cells after you're born that can ultimately become cancerous cells. And you can have the spectrum in between. So the likelihood is that all of us are walking around with mutations in our cells all the time, but they're controlled either by the immune system or these functions that tell the cells to die because they're not normal, or because they're what we call silent mutations, which really have no consequences on function, but we're accumulating mutations all the time. So 3 major steps to become malignant, and some of these might take more than one mutation to get there. So in order to become a tumor, a malignant problem, a cell has to become, 1, insensitive to those anti-growth signals that tell it to stop growing, or it has to start producing its own pro-growth signals. It has to become insensitive to this process called apoptosis, which is a programmed method of cell death, which is what cells are supposed to do when they're not normal. They're supposed to, for lack of a better term, commit suicide. And they have to be able to duck out of the way of the immune system, because the immune system is programmed to see stressed and damaged cells and kill them, because obviously we don't want them around if they might be dangerous. So you might wonder, how does anybody ever get a tumor? That's a pretty high bar that you're setting up. And it's through this accumulation of DNA mutations. And we estimate that there's about 690,000 errors in every single cell every single time that cell divides. So the question might not be, how does anybody get a tumor? It should actually be, why doesn't everybody have multiple tumors all the time with that rate of mutations? And so, the answer is really that we have some mechanisms to help to protect us. So this is just the math to kind of show you this. And I want to kind of talk about why we don't get those tumors. And it's because we've got these guardians helping us out. One of the big important guardians are these things called DNA repairs. And these are genes that are involved in fixing broken DNA. So it's not absolute death if a cell isn't healthy or if it has a mutation. We have certain proteins in our cells that can actually go back and proofread and fix things. So, as I said before, you might have a mutation that doesn't matter. We also have genes that are called tumor suppressors. So these are genes that are kind of the ones that turn on proteins that say, this is an unhealthy cell, you must now die. We can also have genes that are involved in the immune system that help to kill the cells off. And it's only after we've overcome those three sort of classes of genes that you might get a tumor. Most of the time, those 690,000 mutations get rescued by DNA repair genes, and the cells can continue to divide. I do also want to point out that if we never had any mutations introduced in our DNA, we would never have evolution, and we would all look exactly the same, and we would all be susceptible to the same diseases. So this is kind of a counterbalancing mechanism. You want to have some level of mutation in your genes. So here are those three genes that I just talked about again. The first are these oncogenes. These are genes that drive a cell to grow. These are pro-growth signals, and these are things that say go, go, go. An example of an oncogene would be the KRAS or the RAS family of genes, which will come up when we start talking about precision medicine. The second group of genes are the tumor suppressor genes. These are the genes that tell the tumors or cells that have fallen off the rails that it's time for you to die or it's time for you to stop growing. So those are the anti-growth signals. And then, of course, those DNA repair genes, which are all, so important in fixing those mutations. And the last set, which are kind of new to the party here, are these immunologic target genes. So these are specific genes or biomarkers that might vary person to person. But all of these four categories of genes are things that might contribute to cancer, but might also make different people's tumors different. So, for example, if you had a mutation in an oncogene that left it on all of the time, that's a different problem than if you have a mutation in a DNA repair gene. So if I could tell the cell to stop dividing, it wouldn't change the fact that it wasn't able to repair its genes, for example. And so when we start thinking about things in these types of categories, we can start thinking about what's the most precise way to kill a cell that's growing too rapidly. And if you can get more precise about it, you might actually be able to stop a lot of those side effects, and you might be able to target the tumor in a more effective way. In other words, we don't need to use a cannon to kill a fly. So everybody's tumors are different, and we think in the world of precision medicine that if we can understand what their tumors look like, that we might be able to more specifically target them. So think of tumors as a cell that has evaded normal mechanisms, that if we can restore some balance in those mechanisms, we might be able to better treat them. And that's what we're trying to do with precision medicine. So it turns out that there are certain genes that are, hallmark features of a lot of cancers. So every gene in the human genome, or every gene in our collection of genes, doesn't have the capability to give rise to a tumor. And some of them really, really rise to the top in terms of how dangerous they might be for cancer. So I mentioned KRAS before, I mentioned BRCA. Another one is TP53, the guardian of the genome. Those are sort of the heavy hitters in the cancer world that we really want to know. But as I said before, not everybody is going to respond to treatment in the same way, and different people's tumors will be driven by different components of their genetic, background. But there are some commonalities in that. So not every single patient needs their own treatment necessarily. But if you could take this group of patients that have these heterogeneous tumors, look into their DNA and ask the question of who's causing all the problems here, then you can stratify them into different treatments that more precisely target their tumors and allow for better outcomes in there with fewer side effects. That's what we're trying to do with precision medicine. And I want to draw the parallel between precision medicine and personalized medicine and really underscore that these are not the same thing. So personalized medicine is where you've designed a treatment for every single person one by one. So my example here is a CAR T cell, where for every patient that gets a CAR T cell, we have to make an individual product for that patient, and it only works for that patient. That's different from precision medicine, where you say, we have 3 different kinds of drugs, they target 3 different phenotypes of this disease, and we're going to put you into categories. So think about this as, sort of making a pair of prescription eyeglasses for a person versus being able to go pull a pair of reading glasses off the shelf at Costco. You just choose the one you need, but they're all pre-made and ready for you. And that distinction is important, especially in the Canadian healthcare system, where, you know, cost effectiveness and ability to deliver care, you know, are sometimes very limiting commodities. So having something that you can take off the shelf is actually something that makes it more accessible to us. So as a Canadian immunologist and a Canadian cancer biologist, I'm really excited about precision medicine. So this is just my sort of summary slide for precision medicine and you know what we're thinking about. But essentially, all we're trying to do in precision medicine is query the genetics and sometimes the other characteristics of a tumor to categorize the types of treatment that that patient might benefit from. And I want to underscore that there's not a treatment for every single configuration that might give rise to a tumor, but that this is the way that we're starting to think about tumors. So we've identified classes of tumors that can be targeted more specifically with drugs. We've also identified classes to say, you know, this responds to this chemotherapy better than this, or this responds to this particular metabolite or, you know, nutrient better than others. But there's also some cancers for which we say, you know, we don't have a better treatment. That's still informative though, because that says, you know, don't try drug X, Y, and Z. Those aren't going to be better for these patients. And it also identifies where the research needs to be done and made better, and where we need to learn more still. So this is actually my last slide, and just to sort of help to orient you to the terminology that I think Cassadie will probably, you know, jump from. And these are just I touched on these a little bit in my talk, but the three considerations or categories that we're thinking about when we're thinking about precision medicine. So the first are those germline mutations, or those mutations that you're born with and you carry through your families. These are things that might put not only you, but your family members at a greater risk for developing cancer in their lifetime. These are really informative because they're targetable. So, you know, mutations in BRCA, for example, can underscore a few different types of cancers, but there's also drugs that can be given to patients who have tumors that are driven by BRCA mutations. So knowing that you have a BRCA mutation not only affects your treatment, but may have knock-on effects for the rest of your family. And it's something that you might want to talk to your genetic counselor about. A tumor mutation is a mutation that happens only in your tumor. So that's not something that's passed on amongst family members. And those are typically things that happen downstream of a couple of mutations that lead ultimately to cancer. And the third category are these immune targets, or features that help tell us how to tell the immune system how to go after a target. So you'll hear terms like microsatellite instability, for example. So tumors that have acquired a whole bunch of different mutations that make them, you know, sort of, they put them in a different category for therapy because we can give them immunologic targeting therapies, or mutations that allow for the generation of neoepitopes. You've all heard a lot about vaccines this year. We can make vaccines for cancer, and we can make vaccines against specific, tumors when they have a flag that the immune system can see. So those are immune targets. So I'm going to leave it there and maybe pass off to Cassadie. But if anybody has some questions, or we can have a quick discussion now, I'm definitely open to that.
We got a couple of questions in the chat, if it's okay for me to ask them on behalf of David. He says, many tumor precision medicine mutation reports only list a few mutations. Are they only listing the ones that might be actionable, and is there a more exhaustive list provided to the doctor?
Good question. So it depends on the genetics, the setup of the genetics lab and what was actually done. So depending on where you are in the world and who your physician is, and, you know, a number of other characteristics, the answer is maybe. So we in Halifax do these panels for patients that are a curated panel. So we say, for example, these are the 10 most likely genes to drive a tumor. And we want to know whether or not there's a mutation in all of them. So they'll be screened only for 10 genes. It's cheaper, it's faster, it's easier to do in terms of manpower. And then the clinician will get a report back that says, you know, mutation in gene XYZ. Other places will do larger panels, or for other tumor sites, they'll do larger panels where they'll read through a lot more genes, but typically the report that goes back to the physician is only the genes that might matter for that tumor. And when I say might matter, what I mean is that we know something might matter for that tumor. So there are always people doing more research on more genes, And it might be true that 5 years from now, if you ask the same question, they might say, oh, gene ABCD is actually important, but your physician didn't know that 5 years ago, and neither did the genetics person. So yeah, it happens that sometimes there's way too much information to report back to the physician, so they only curate the information that's most important and relevant at that point. But that information is always stored. So it may also be the case that your tumor is assessed today, and 3 or 4 years down the road, there's more, information available, and your physician can go back and say, hey, do you remember David? Can you check and see if he's got this going on?
Yeah, Stacy was asking, does precision medicine make sense for stage 4 pancreatic cancer that has spread to other organs like the liver?
Yes, absolutely. So again, within the caveats of what can be done for your cancer. So it's always worth having the conversation with the med onc and saying, do I have targets? What are they, and is it worth it? But targets can also be, not necessarily curative, right? They can just be targets that slow things down. So there's opportunities in terms of quality of life and that sort of thing to be had. So yeah, it's always a conversation. What do I have? What do you think I can do? And my biggest, strongest recommendation is that you get a genetic counselor involved as often as you can, because keeping up with those mutations and those opportunities it's a more than a full-time job. So, the med oncs have lots of other things on their plate, and it's the genetic counselors that are able to pick those things up quickly for you.
I'm going to jump in there just for 1 second as well with Stacy's question too. And it's making sure that you have a specialists that are willing to work with you as well. So, understanding clinical trials, where pancreatic cancer has this, stigma within the healthcare system, where, in Canada and in the United States and other countries, we see that, I've seen numbers anywhere between 45% to over 60% of patients not being treated. So precision medicine, besides all the obvious benefits that you've described in your presentation, it goes back to that quality of life, as well. It's and you're not going to get into those opportunities unless you have a medical oncologist that's willing to look at, your bio, like when you have genetic testing, and is agreeable, and hopeful and wants the best for their patients in terms of understanding the benefits of treatment.
Stephanie, might be the time, because sometimes oncologists just don't have the time, and they find it overwhelming to do more work than standard of care. I know I've seen that in our regional center.
Yeah, it is really challenging, and this is something that for those of us that are in Canada, that we're trying to approach with. There's a new initiative through the Terry Fox Marathon of Hope Cancer Centers, where they're one of the things they're trying to do is build cross-Canadian collaborations where the workload of this doesn't necessarily need to fall on the treating physician, but instead would fall on working groups across the country. So rather than expecting your medical oncologist to be able to, know all the details of your tumor and their mutation, there would be working groups kind of over Zoom meetings where, you call in the people that are relevant for each patient and discuss what those things look like. So it opens the opportunity to say, what, we had another patient with a BRCA mutation, stage 4, blah, 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 blah. This is what worked for them, and start to build that expertise up. So instead of expecting every doctor to know everything, you expect some doctors to know some things and at least talk to each other. And the researchers are involved in that too. So we can say, hey, we've got a drug that works in this other type of cancer, let's apply for compassionate use and this sort of thing. So I think, as Stephanie says, you need a doctor that's encouraging and doing that. And I think as people who are seeing those doctors, encouraging them to be involved in these types of things can also help to make them, feel less like they have to do it all by themselves and know that they have some opportunities there.
Where do we find out more about that, Jeanette?
So it's done through the Terry Fox, the Research Institute, but I can send Stephanie the information on that. I want to underscore that that's still very, very new and in the earliest phases of it, but that's, we see that problem and we're working on creating pathways to make that better.
And I think
Fantastic.
it's a global issue. You know, like I know that Julie Fleshman with PanCan has done extensive work, and you know, you can correct me if I'm wrong, but I'm thinking that in the States that they were looking at pancreatic cancer patients in clinical trials, and I think that it was like they were celebrating 11%. You know, and 11% is still, you know, when we look at that number, it still seems so small. I know in Canada it's even smaller, but it's, you know, it's so important because we know that patient outcomes in terms of, you know, life-sustaining and quality of life is better when in a clinical trial. So you just mentioned, and actually I see Alina here on the call about compassionate access. Can you?
Only superficially can I talk about compassionate
Okay.
access, but
Yeah.
there are pathways. So let's just say there's a drug we know that actually, I can give you a great example. There's a personalized oncogenomics program in BC that does this. They sequence tumors and then they look for what might work. And there have been cases where they've identified, in one case, there was an advanced tumor refractory to everything they tried. And they had a signal that said it might be associated to something to do with cholesterol metabolism, which made no sense based on the pattern of what they called this tumor. But they were out of options, so they tried it. And they were able to ask for compassionate access to this drug that's off-label for cancer, on-label for other things, so safe to use in people, and treat a patient with it. And the patient actually responded as predicted. So all we mean, I guess, by compassionate, it's a fantastic story. They've got a few of them now.
Mm-hmm.
Anyway, compassionate access is really just saying, like, I know you don't normally use this drug for this, or I know that this drug isn't typically available to these patients, sometimes for financial reasons. And you can appeal both to Health Canada and, you know, probably the FDA, and to the drug company, depending on what the right pathway is, to say, listen, can you please just let me use this drug for this thing? So if it's financial, you ask the pharmaceutical companies, and if it's kind of just practical because it's off-label, you ask the government agencies. And that's something that's done through the physicians. But again, they have to kind of be willing to put the paperwork in, you know, to do it.
There's just one more question from Lori, and she was asking, are there many labs that do genetic testing for pancreatic cancer in Canada, and do they all use the same methods?
Many labs, yes. Methods, no. Methods are different all over the place. It's the Wild West. But there is an appetite amongst, usually it's the researchers or the med-oncs that are pushing the genetic labs to upgrade their testing. So new tests are coming out all the time. New biomarkers are identified all the time. Usually what will happen with your genetic testing is that it's collected wherever you are and then shipped off to some big lab. So for us, everything in Atlantic Canada, I'm not sure about Newfoundland, comes to Halifax for its testing. You know, most things in Ontario would probably go to Toronto, et cetera, et cetera. But that's okay. We can ship DNA through the mail pretty easily. And then so once it gets there, they do whatever their local clinical lab has decided is the right panel for pancreatic cancer, and then off they go. Those panels come from manufacturers. So you'll hear names like Illumina or NextSeq. And so these manufacturers will create, you know, sort of a menu of genes, and they'll say, this is what are the most likely genes to be actionable and or problematic, informative, I suppose. And then they'll run you through that panel and then report back on what's important, as I was talking to David about, and what's in there. But no, there's no rule to say that they all have to be from the same manufacturer or through the same platform. And a lot of that just comes down to, you know, regional preference, the type of machine they have, you know, whatever the geneticist wanted to use. Often the genes are the same, but the actual way to do them is different. And the number of genes that's queried changes depending on how caught up they are to kind of the times, but it changes all the time.
Okay, and then she has a quick follow-up asking about what is the difference between the genetics of the tumor and the DNA that would be found in your blood?
So the genetics of the tumor can be mutated. So if you wanted to have your tumor sequenced, we'd need a biopsy from your tumor. So what you would find in your blood, though, would be the same as you would find in your skin, as in your cheek, as in, you know, anywhere else in the body. the thing that makes cells different, cell like tissue to tissue, is the genes that we turn on and how much we have them on. So the genes shouldn't change from one healthy cell to the next, be it blood or skin or whatever. But in the tumor, where you've got all kinds of problems in terms of DNA repair and mutation rates, the tumor will start to mutate more, and so the tumor will look different from your germline or somatic cells. So that just means your normal healthy cells in there. And sometimes it can be informative to compare both of those, because you can say, like, not everybody's genes are identical either. So you can say, is this a mutation or is this what we call a normal variant, to identify. So if you compare healthy to tumor, you can kind of get some information there.
Okay, and then one more question from David. He's asking, when will it become standard practice to collect material for genetic testing during the diagnosis and biopsy procedures? Is this among people's suggestions?
Depends where you live. We are pushing, as researchers, we're pushing to get that done for patients now. I think oftentimes in hospitals, they're looking to do it, there's always a cost associated with it in terms of time, and you have to be able to turn it around fast enough for it to, be meaningful for that patient. So it depends on where you are and what kind of cancer you have, but the push is already on. I can tell you that we are pushing very hard at Dalhousie to get this done now for patients with pancreatic. Colorectal, for lung, it's already done reflexively, and it has been for 14 or 15 years now.
And just to chime in the US, the National Comprehensive Cancer Network guidelines for treating pancreatic cancer, I think it was 3 years ago. I'm part of that panel, and we actually recommended getting enough tissue for testing. We were just kind of on the cusp of, we're midway through where we are now with Know Your Tumor, which I'll talk a little bit more about. But we were kind of on the cusp of precision medicine in pancreatic cancer in the US. So we, the clinicians and then me bringing the patient advocate voice, actually pushed for that. And so that was in the National Comprehensive Cancer Guidelines for Pancreatic Cancer about 3 years ago, and is still there. So it's definitely in the guidelines. It's just adoption is the next step.
Stacy was just asking, this is like a bit off topic, but I don't think it's too far off topic. She says, would it be okay to ask on the views of the importance of diet for patients with pancreatic cancer, which we've had a couple caregiver meetings on specifically that topic, but can you speak to that, Dr. Boudreau?
Not much. Not much, without sounding like an idiot. I might refer you back to the other ones, except to say that tumors like to eat. They will suck up all the nutrients in your body if you let them. So it's important to make sure that you're maintaining a healthy diet. There are certain indications where you'll have a mutation, for example, in like the adenosine pathway that feeds the tumor. The tumor will feed itself with all of your adenosine, which is an amino acid. And so there can be opportunities there to give people enzymes against that particular pathway, and help to, sort of modulate whether or not the right food source is available for your tumor. So I think there's a connection there. David's just brought up a connection between epigenetics and diet. I'm not intelligent enough to talk about this too much. So I think it is there, and I think it's worth chatting with your doc about, but I'm going to maybe shut up there.
So Cassadie Moravek is the Associate Director of Scientific and Medical Affairs for Pancreatic Cancer Action Network, overseeing the organization's patient research initiatives, including the Clinical Trials Database and Clinical Trial Finder, the Know Your Tumor Precision Medicine Service, and the Patient Registry. She joined the Pancreatic Cancer Action Network in 2010 as a Patient Services Associate, providing educational support and resources to pancreatic cancer patients and their families. In her current role, she ensures that the patient research initiatives she oversees are meeting the needs of pancreatic cancer patients, caregivers, and healthcare professionals contacting patient services. She also works with her team to collect, analyze, and publish data to disseminate PanCan's findings and contribute to best practices in the field. So welcome, Cassadie.
Perfect. So thank you so much for the invitation. And today I'll be talking about our Know Your Tumor precision medicine service that we offer at the Pancreatic Cancer Action Network through our patient services program. First, I'm just going to touch a little bit on PanCan for those of you that may not be familiar with the Pancreatic Cancer Action Network, lovingly called PanCan. And then I'll touch on our patient services program, and then I'll go into more about our Know Your Tumor program specifically. So first, just an overview of the organization. So the Pancreatic Cancer Action Network was actually founded in 1999, so just over 20 years ago. And right now, our focus really is on a cross the board focus on pancreatic cancer. So we have our research and clinical initiatives teams and programs that really are working to push science forward through our grants program. So we fund pancreatic cancer research. We also have our own clinical studies. We have a stage 4 pancreatic cancer trial, as well as we just last week launched an early detection initiative in collaboration with the NCI in the US. And then we also build on our research community. So all of the grantees who have received research grants, we bring them together as a collaborative community where they can speak to one another and bounce ideas off of one another. We also have a government advocacy portion of the organization that we really work to demand more federal funding for research across all cancers, and specifically pancreatic cancer, and advocate for legislative support on Capitol Hill in the US. We also have our patient services department, which I'll touch on just a little bit more in detail, where we really focus on revolutionizing how pancreatic cancer is treated by connecting patients with the latest treatment options and providing free in-depth disease information for those patients. And then finally, we have a community engagement portion of the organization where we really work to lead and mobilize communities across the country, across the globe, working closely, of course, with Craig's Cause through the World Pancreatic Cancer Coalition, really to raise awareness and funds to fight pancreatic cancer. So one section of kind of one of the big goals of PanCan is to improve patient outcomes, and this is really where I'll focus my talk today. And this is really around influencing funding for pancreatic cancer, increasing clinical trial enrollment rate, collecting data and generating knowledge and making that available, education about the risk and symptoms of pancreatic cancer and early detection, and then influencing smart trials. So all of that is kind of in the realm of what our patient services team, most of that is what they work on. So just to touch on patient services, so it is the helpline that the Pancreatic Cancer Action Network provides to patients, caregivers, and healthcare professionals across the US and the globe. Most of our constituents do come from the US, but we do have a portion coming from Canada, and as well as other countries across the world. And we really do work to provide information based on what the patient's looking for. So we really let the patient or the caregiver lead the initial conversation. We can provide information on treatment options, biomarker and genetic testing, which I'll get into more, clinical trials, any support groups information. We also provide listings of specialists, information on diet, nutrition, supportive care, symptom and side effect management. So really a wealth of information that we provide through our patient services helpline. And so this kind of transitions us into where we're going to talk about today, but we really focus through patient services on getting patients on the right track. So this is really about a 4-step process to get patients to see the right team. So to see a specialist who knows about pancreatic cancer, because we know that patients that see a specialist actually can have improved outcomes based on the research. It's about getting patients to the right tests. So this is where we'll focus today. So I won't spend a lot of time here, but really about getting biomarker and genetic testing and knowing all of the treatment options that are available. It's also about getting patients on the right treatment. So to consider all of their treatment options, including clinical trials. I know Stephanie touched on the current enrollment rate in the US for pancreatic cancer clinical trials is about 11% reported through our helpline of people that are contacting us, but throughout the country, it's actually unfortunately more like 3 to 5% of pancreatic cancer patients are enrolling in trials. So definitely a lot more work to do there. And the right treatment also encompasses getting on a matched therapy when you do have an actual mutation found through biomarker testing. And then finally, the last step of the right track is really to share information along every step. So to share any information about the pancreatic cancer journey, hear from patients, hear what patients are experiencing so that we can help accelerate research. So diving into the right test as promised. So the right test portion of this right track, which is about patients getting treated with matched therapies. And we know through research that if patients get treated with matched therapies selected through biomarker testing, which is the testing of the tumor tissue itself, they have better outcomes. And genetic testing for inherited mutations may also reveal mutations that suggest specific therapies may be beneficial. So as Dr. Boudreau mentioned, the genetic testing for inherited mutations are those mutations that are passed down from your parents. And those are the ones circulating in your blood, found in your skin cells and your cheek cells. Those are the ones in your saliva, really found throughout your body. And then also, because of our Know Your Tumor Precision Medicine service, we're able to identify treatment options for healthcare professionals and for their patients. And when we surveyed individuals who contacted our patient services helpline, known as Patient Central, 51% actually mentioned that they considered biomarker testing. So it's actually quite impressive that a lot of patients are considering biomarker testing, but there's still that 49% that we need to continue to educate and make aware of the possibility for biomarker testing. So that leads me into, I think, the burning question. We had a couple of these. So where can patients obtain biomarker testing and genetic testing for inherited mutations? So I mentioned the National Comprehensive Cancer Network, which is known as the NCCN, and then also the American Society of Clinical Oncology, known as ASCO. They both have recommendations for pancreatic cancer patients when it comes to precision medicine testing. So the NCCN specifically does recommend genetic testing for inherited mutations. So again, that's the germline testing that Dr. Boudreau spoke about for any patient diagnosed with pancreatic cancer, regardless of stage. And then also biomarker testing of the tumor tissue. So this is getting an actual sample of the tumor itself and providing testing on that is recommended per the guidelines for those patients with locally advanced or metastatic pancreatic cancer. So those patients that don't have a tumor that can be upfront removed by surgery. And so that's where the guidelines currently are. And because of that, in the US, insurance companies are actually starting to fairly broadly cover the costs of these testings outlined in the guidelines. We know this isn't the case across all countries and across the world. So there definitely is, there are disparities based on where you are when it comes to accessing any sort of precision medicine testing. So at PanCan, kind of how we talk to patients through our helpline is letting them know that if they're at an academic or high volume institution in the US, they very well may be getting biomarker testing done through their healthcare providers, through their doctors. And that can provide a number of benefits. They actually can get the tests back sometimes quicker because the processes are already set up at the institution level and it's a very well-oiled machine. The doctor often has confidence and familiarity with the testing that is done consistently at their academic institution. And oftentimes this makes the process easier for the patient. However, we know that in the US alone, only 20% of patients are actually seen at an academic or high volume institution, and that leaves the other 80% seen in places that may not have precision medicine workflows worked out to get patients biomarker testing or genetic testing. So for patients who are being seen in a community oncologist without access to testing, or even patients who don't have insurance coverage for testing or are uninsured, we actually have our PanCan's Know Your Tumor Precision Medicine service where we can actually provide the testing free of cost for patients for the testing itself. So I will pause there for questions before I jump into the basics of Know Your Tumor. So if there are any burning questions, I'm happy to take them now.
I was just gonna, I just posted something in the group, at least for Canada. I know that Canadians were worried about the impact that genetic testing would have on coverage. and what patients would be covered for. So for instance, if they, had a genetic mutation, would they still be covered for treatment? And I just posted about the Canadian government passing a law to not discriminate. So, it would be against the law if their insurance company discriminated against them because of the genetic testing they had. That would maybe lead to future treatments.
Yeah, that is an excellent point. And we have a similar law that's been in place in the US for a number of years. So I definitely think that the legislation is catching up with the science to make sure that patients are protected and that they do have insurance for anything that might be found in their genetic testing. All right, so I will jump into the basics of Know Your Tumor. So first, just what is it? So Know Your Tumor is a pioneering precision medicine service that really may help identify better treatment options for patients. PanCan recognized about 7 years ago that the rest of the cancer field was moving forward with precision medicine. It obviously had been around for lung cancer for a number of years. I think it's been 15 years now that lung cancer patients have been receiving personalized or precision medicine for their treatment for lung cancer. And so we set out to determine, could we do this in pancreatic cancer? Is it even feasible? Are doctors going to be on board? And ultimately, are we going to find anything in pancreatic cancer that is actionable? We know from Dr. Boudreau's presentation that all cancers have multiple mutations, but is there going to be something that can be used to help find treatments for pancreatic cancer? So we launched our Know Your Tumor Precision Medicine service back in 2014, and it's accessed through PanCan's Patient Services Helpline, and it does provide patients access to biomarker testing of the tumor tissue. So again, taking a sample of the tumor and performing tests on that, who may not be able to access or afford testing otherwise. And really, when we set out to do this, we were working in a space that this wasn't common. And so we actually were working with a lab that actually, it was a company that coordinated the testing. So it worked with the doctor to make sure that they knew everything they needed to know to complete the testing. It worked with the patient to guide them through the process. And ultimately, the tissue that was collected was sent out to a couple different testing labs. And then we were paying for the coordination of all of that. And so the testing labs were actually billing patient insurance for the testing. And once we kind of got our hands around that, figured out the process that started becoming more commonplace, actually last year, we were able to switch to partnering with a testing lab specifically. So now PanCan covers the cost of the testing for the patient. So I think this is probably why it has become a little bit more known now and communicated that the testing itself is free through our Know Your Tumor Precision Medicine service, because PanCan is now paying for the biomarker testing. So any fees that the patient would see in the US, of course, would be co-insurance or co-pays as part of the biopsy to get the tissue, but the testing itself wouldn't be billed to insurance. And then, of course, for patients in Canada, you'll get the biopsies through your doctor and through the healthcare system there. And then, of course, PanCan covers the cost of the testing. And as we've discussed, biomarker testing can provide the patient and their doctor with information to help them make a better treatment decision. And also it helps to gather information about what is known about the genetic changes in pancreatic cancer. So I'll talk a little bit later about some of the publications that we've been able to get out there into the community about what we're learning through all of the patients that have participated in Know Your Tumor. So this service really was twofold. One, to be able to provide profiling molecular testing for patients, and then two, be able to learn from those patients to be able to help future patients and potentially even help design smarter trials. So the current eligibility requirements for the Know Your Tumor Precision Medicine service through PanCan is a diagnosis of a pancreatic cancer malignancy, pancreatic cancer. So we don't say this is only for adenocarcinoma, we do testing for pancreatic neuroendocrine tumors, the rare exocrine tumors like adenosquamous, and then of course the majority of patients have adenocarcinoma. So we do this across the board for any patient with a pancreatic cancer diagnosis. And then we also have to make sure that the patient actually has tissue that can be obtained. So we are doing biomarker tissue testing. And so we need a sample that we can actually test. And the lab that we're working with does require that it's less than 6 years old, but there's always wiggle room here. So if there is older tissue that's available, it can be used on a case-by-case basis. But as we talked about, sometimes as of course, the testing gets better over years, sometimes that tissue may be not as easy and relevant to test if it's 6 years old. And obviously, if somebody has a recurrence, their tumor might have picked up slightly different mutations. So it's always good to test a fresh sample. And then the other requirement is just if the patient is receiving care in the United States, Puerto Rico, or Canada. And this really comes down to getting the tissue and the samples across borders. And we found that those are the easiest to get the samples to our testing partner who is based in Illinois in the US. So that's really the current restriction there. And then we also just need to make sure, because we are consenting these patients and providing them an authorization form, we need them to be able to read and speak English or Spanish, or have a close caregiver that can interpret and act as a proxy for them. And then also just that the patient isn't imprisoned. So now that we've gone through eligibility and what it is, let me just walk you quickly through the process. So as I've mentioned a couple of times, Know Your Tumor is accessible through our patient services helpline. So our patient services helpline staff discusses Know Your Tumor with the patient or the patient's close caregiver. They send the authorization form to the patient to review, fill out, and then that authorization form comes back to the patient services staff. And then once we review the authorization form, that authorization form gives us permission to provide the patient's contact information, doctor information to our testing partner, who is Tempus. And Tempus is a CLIA certified laboratory, which is a certification that most of the testing labs that deliver reports back to doctors for clinical implications, for treatment implications, have to have. And they're the ones that are performing the tumor biomarker testing, and then a term that we haven't quite heard yet today, which is matched normal sample genetic testing. So what Tempus does is they actually test the tumor tissue itself, and then they also get a blood or a saliva sample from the patient that is a normal sample that would only have the germline mutations, the ones that are inherited from your parents. And they do that so that when they are providing the report, they can identify which of the alterations or genetic changes are found only in the tumor tissue versus ones that are actually passed down from your parents. And that's because that can have different implications on testing, because there are treatments in the US that are approved for those mutations that are passed down from your parents, those germline mutations, but aren't approved for those mutations only if they're found in your tumor. So it's so that they can delineate that information. And then they also do testing for tumor mutational burden, which is the amount of mutations found in the tumor tissue, and then microsatellite instability, which was also mentioned previously, and both of those have implications for if the patient may respond to immunotherapy. So that's Tempus. So when we pass the patient information over to Tempus, Tempus actually reaches out and talks to the doctor. So they let the doctor know, hey, your patient wants to do this service. Here's what it looks like. Here's what we need from you. They send the doctor the order form, and then the doctor fills out that order form and sends it back to Tempus, and that starts the process. So then the doctor provides the tumor tissue and then the blood or the saliva sample from the patient, and that's received by Tempus. Tempus does that testing that I mentioned, and we actually use Tempus's XT panel, which is really in the weeds, but we test just over 600 genes for cancer. So we do a really, really broad panel through Tempus. And so, David, to your point, there are probably a lot of things found that we don't actually show on the report because they're not potentially actionable right now, but there is like a very complicated file that the doctor could have access to that has all of the sequencing results on there. And so once that testing is completed, Tempus puts together a report outlining the actionable mutations and any of the mutations that are found only in the tumor versus found in the blood sample. And then that report is sent to the doctor, and then the patient services team also gets a notification. And so what happens is that the doctor will usually have a conversation with the patient about the report, but at the same time, our patient services staff follows up with the patient to let them know that the report has been sent to the doctor. We ask if the conversation has been had with the doctor about the report, and if not, we encourage the patient to go ahead and reach out to the doctor to ask about the report and to start that conversation. And then we also do a touch point later on if there is a treatment that would be potentially beneficial to the patient, or if there's a clinical trial that the patient's interested in, to actually assist patients with any challenges obtaining access to a treatment or access to a clinical trial. So I'll show you, this is very tiny, and I do not expect you to read the report on the left, but it is just a fake report, even though there's what seems to be a real name on it. But this is just a sample report of what would come out of our Tempus labs. But basically there is a section on genomic variants, and these are the potentially actionable mutations that are found in the tumor. There's also a section here on germline mutations, which are those inherited mutations that were also found in the tumor. And then there is a section on kind of areas that are normally found in pancreatic cancer, but there is no reportable information found in those areas. And then finally, there is immunotherapy markers. These are the tumor mutation burden and the microsatellite instability status to determine if immunotherapy may be an option. And then finally, a section on treatment implication, and then several more pages on treatments that might be available. So those potentially actionable mutations or alterations means that these results could impact the treatment available to the patient. It may mean that there is a treatment that is targeting a patient that can target tumors with these particular mutations. It could mean that there is a mutation found that shows that there's actually a treatment that we know won't work for these patients, so this patient shouldn't receive it. And so some of the approved treatments in the US for pancreatic cancer patients with inherited BRCA1 and 2 mutations, there are treatments approved for that. There are also treatments approved for a particular type of genetic alteration that's an intract fusion, which is actually where one part of a gene fuses to another part of a gene. And that only happens in about 1% or less than 1% of pancreatic cancer patients, but there are actually 2 treatments approved in the US for those patients. And then also there are clinical trials that are being designed to study new therapies by the type of tumor mutation rather than the type of where the tumor arises in the body. So clinical trials, or biomarker testing results, even if there isn't an approved drug, there may be a drug available through compassionate use, which we discussed previously, or there may be a drug available through a clinical trial that is just brand new. They're trying to determine if it works, or maybe they know that it works in the lab and they're trying to see how it works for humans. And then the tumor mutational burden and microsatellite instability can indicate if patients may respond to certain immunotherapy treatments. And there is currently an approved immunotherapy in the US for patients who have MSI high, which is microsatellite instability high. So they have a lot of microsatellite instability, or a lot of mutations in their tumor. So there is a treatment available for that in the US. So lots of information can be found, and this is a sample one, so there is lots of information here that was found. So I will answer my question. So basically any patient in the US, Canada, or Puerto Rico with pancreatic cancer is eligible to participate in Know Your Tumor as long as they have tissue available for testing. So that is that pause. And then I will go into just a little bit of the impact from our program. So to date, we have actually profiled or had have provided testing for over 2,500 patients with pancreatic cancer. 96% of those patients that were enrolled in the service had successful biopsies, which meant that there was enough tissue available to be tested. So sometimes the samples that are collected, there isn't enough cellularity, enough tumor cells in that sample for the testing to be successfully completed, but we do have a 96% success rate, which is good. And then we also have completed almost 1,600 reports. So that means that those are the number of people that actually completed the testing. So we do have, obviously, there's about 1,000 people that haven't. Some of those are still in the process. But others of those, they just weren't in the right place. Maybe there wasn't tissue available. They weren't able to get a biopsy early on in the program. A number of doctors weren't on board with testing. That's definitely changed, which is good. And then sometimes patients just weren't in the right place. When talking to their doctor about the program, the doctor said, "You're doing really well on treatment. I don't want to biopsy you right now. We don't have any tissue available for the testing. So let's just wait and we'll do it a little bit later." So there's a lot of reasons that lie in there. And then unfortunately, some patients had passed away before the testing could be completed. So there's definitely a widespread there. I'm happy to report that the completion rate is getting better over time. With a lot of this is from early on. And then we've also seen in the US, 48% of the patients that are completing the process are actually coming from the community physician practice. So there's an asterisk here because for the first 5 years of the program, that rate was about 32%. But for 2020, when we looked at the data, it's actually 48% for the year 2020. So it's definitely increasing that more community practices are accessing this, and I think less. I think we're seeing the community numbers increase and the academic numbers decrease as academic institutions have access to their own testing. And then we have 49 states with patients enrolled in the US. We have patients from Canada. We have a couple from Puerto Rico. And then, of course, DC, which is not a state. We also have patients from there as well. So definitely a wide reach for the program. And then through the program, we've also been able to do a number of publications. So there are 6 publications that we've had actually printed in multiple peer-reviewed journals, and I'll talk about 2 of them, and just to kind of give you a taste of the difference over time. So back in 2018, we looked at the first 640 patients who had completed the testing. And on the left here, you will see this acronym NGS, which is next generation sequencing, which is the type of genetic testing that we are using for the tissue testing. And on the pie chart, you'll see that 27% of patients actually have, in this purple section, highly actionable mutation, meaning that there is a mutation that's found, it's felt to be driving the cancer, and that there is a potential treatment option available through a clinical trial, an off-label fashion, potentially compassionate use. So there's definitely a sliver, a fourth of patients are falling into this bucket. There's about another fourth of patients that fall into the bucket of they have a mutation that may modify their options. So it's in the pathway of where there are treatments available, but we don't know quite yet if those treatments work for those patients. So a lot of this is in clinical trials and trying to determine if that works. And then there's about 50% of patients who have a mutation that isn't actionable. So David, to your point, there are lots of mutations that are found that just don't show up on the reports because there's nothing currently implicating their care. So over on the right here, I have just listed out some of those highly actionable mutations that we're finding through our Know Your Tumor program. And I'm not going to go through all of them, but here on the left, there's just a handful, and these are in various numbers, obviously. Some are higher incidence in pancreatic cancer, so BRCA1 and 2 is more common, it's still only 5 to 7%. And a lot of these down here, the ROS and ALK, there's maybe only like less than 1% of patients have these types of mutations, but you can see that there are treatments available. So fast forwarding to 2020, so just last year, we actually had a publication in the Lancet Oncology And this was publishing, actually, we were able to look at the overall survival in patients with pancreatic cancer who received a treatment based on the biomarker testing that they had. And so the other very important point of Know Your Tumor is that we actually are able to follow up with the patient's doctor to see what types of treatments the patient is on and how well they do on those treatments. And so this paper was looking at that data. And I just wanted to point out this chart in the right here. It's showing that still about 1/4 of patients have an actionable mutation. So we're pretty consistent with about 25% of patients have an actionable mutation in pancreatic cancer. And we looked at 3 groups of patients. So we looked at the patients who had an actionable mutation and were treated with a matched therapy, which is the matched group. We looked at a group who had an actionable mutation but weren't treated with a matched therapy for whatever reason. And then we also looked at those patients who didn't have an actionable mutation found. And so the main takeaways that we found from this paper actually were that patients who received matched therapy for a mutation that was found actually had significantly longer overall survival than either of the other 2 groups of patients who had an actual mutation but didn't receive matched therapy or didn't have an actual mutation. So on this graph on the right, you can actually see that patients who received a matched therapy survived on average 2.5 years, whereas patients who didn't receive a matched therapy but had an actual alteration only survived about 1.5 years. And again, these are averages. This is the median. So there are people surviving longer than this, but still very impressive that we were able to see through this real world data. This isn't a randomized trial. This is real world data from patients and their clinicians that they are surviving longer when they receive a matched therapy. So just wanted to throw in another quick question. So what percentage of pancreatic cancer patients did we just learn have an actual mutation?
%25?
Yes, excellent.
Yay.
Yes, so it's about 1/4 of patients. So just to conclude with a few remarks and then definitely want to open it up to more questions. So patients absolutely should talk to their doctor about precision medicine testing, including the biomarker testing of the tumor tissue itself, as well as the genetic testing for any inherited mutations that were passed down from your parents. Precision medicine testing may change the treatment options available to patients. So there may be 25% that actually have a mutation that is potentially actionable and can impact treatment options. But there are still a number of treatment options available for the 75% that didn't qualify, including clinical trials and standard of care treatment options. Also, pancreatic cancer patients who have an actionable mutation and receive matched therapy do have better outcomes based on what we're seeing out of the Know Your Tumor program, as well as some other publications. And ultimately, just encourage anyone who's interested in learning more about precision medicine testing options or more about Know Your Tumor to reach out to our patient services call center. And I just put the contact information here. So I will stop there and take any questions.
David was asking, what happens with the data used to identify matches between biomarkers and effective treatments? Several private companies perform a similar service to PanCan's Know Your Tumor. And is all of this data shared, or are there data silos that each group hopes to profit from?
Oh, David, that's an excellent question. So it vastly depends. Some of this data is publicly accessible. PanCan is actually working to make the Know Your Tumor data, specifically the data that we have access and control of, actually accessible to researchers. So we've actually started our Spark data sharing platform soon to launch that actually will make Know Your Tumor data available for researchers. There are also other databases out there that do share this type of data, but it definitely isn't across the board for every single company. The good news is that some of those companies are publishing on their own data, so it is getting out there in a published form, and oftentimes they have to publish at least a portion of their data set, so that data is getting out there into the world. But definitely PanCan is working to help break down those silos. Number one, through our Spark data platform, providing access to the data that we're getting. And number two, by gathering it from patients and encouraging patients to share it through patient registries that are across cross-collaborative and really available to multiple researchers to be able to access.
Thank you. And then Lori I think she was referring to a slide a while ago that listed 2,581 patients enrolled in Know Your Tumor. She said that number looks low, and why isn't there more?
That is an excellent question, Lori. So I think when we launched the program, we actually thought we were going to get 3,000 patients in 3 years. We were like, we're gonna get testing for everyone. And honestly, there continue to be barriers to doctors wanting to access this, to patients wanting to access this. I think when it comes to patients early on, a lot of patients had hesitancy of getting a second biopsy because back in 2014, it wasn't common to be able to get enough tissue at the time of diagnosis for pancreatic cancer. Usually for diagnosis, the doctor would just get enough cells to be able to say, yes, this is pancreatic cancer. We know that this is adenocarcinoma, and here's what we're going to do about that. But there wasn't enough tissue to be able to run the actual test. And so early on, we actually had some hesitancy from patients because they didn't want to go through that biopsy again. Maybe they had a rough first experience, or they've had family members who had challenging experiences and they didn't want to go through it again. So that definitely has been a barrier early on. It still continues to be a barrier for patients if they don't have enough tissue for testing. And then honestly, kind of the tides have shifted a little bit in the US, where more and more patients are getting access to this type of testing through their doctor. So most recently, we have been collecting data on patients who contact our call center and asking them if they've already had testing. And we're seeing that number inch up like month by month. I think right now we're at about 16% of patients who we ask that question to already have received testing through their doctor themselves. So it's a little bit twofold of kind of barrier issues as well as increased adoption of this in the actual clinical setting. The other thing is that obviously we're not reaching all pancreatic cancer patients. We only have about, I think on average, we talk to about 14,000 new contacts through our call center. And sometimes those are from multiple family members. So we're less than 14,000 patients that we're touching. So yeah, definitely would love to see this number a little bit higher, but right now it's hopeful that patients are getting access to this elsewhere.
I think for us here in Canada, and I would say other countries as well, is that, we as an advocacy group need to do a little bit better in terms of making physicians aware of the programs that are available as well, because many don't know that, patients have access, in Canada to the Know Your Tumor program. And, that's certainly going to be part of our messaging moving forward when we're having meetings about patient programs that are available, is to let everyone know that this program exists, and it's extremely valuable. And, up until it was really, I think, Lori and Sandy that had introduced us to know that Canadian patients could access this program. It was $6,000 or $7,000 that patients were paying, and that's just not, accessible to many, many people.
Yeah, absolutely. And yeah, definitely welcome everyone spreading the word. I see, Lori, you have a question in the chat about giving the KYT info to all Whipple patients. Absolutely spread the word. Anyone is eligible regardless of the stage of pancreatic cancer. I think patients who are surgical patients, obviously there's a lot more tissue available because they hopefully are removing the entire tumor. And so that's a little bit easier. There's not a biopsy challenge in there. So definitely pass along the information. We do enroll patients who are surgical patients, and obviously it may have implications for maybe their post-surgical treatment. Or if there is a recurrence, they then know a little bit more about their tumor for selecting future treatments. So definitely encourage the spreading of the word and echo what Stephanie says, that definitely just getting the word out there and letting people know that these things are available. I think the other thing just to mention, just from an international perspective, a lot of the testing labs in the US do also have international programs where they're able to work with patients outside the US and outside of Canada. So it's definitely good if you're talking to patients internationally to encourage them to reach out to the testing labs themselves. They may have programs, and I've also recently learned that there are sometimes kind of self-pay options at these testing labs that cost considerably less than if they were to bill your insurance. So I think there's definitely a lot of options out there, in addition, of course, to the Know Your Tumor service.
Thank you, Cassadie. And then we just had one more question from David. He said, I just had a forum member report back that their doctor refused a liver biopsy because of the risk of more metastatic spread by doing the second biopsy. Have you learned about the potential spread from biopsies?
That is an excellent question. I am not an expert in this field. I do know that there are risks, and there is risk of seeding from biopsies, especially percutaneous biopsies, which are generally the ones that are used to get a liver biopsy, where they actually go through the skin in the abdomen as opposed to an endoscope down the throat. So it is possible. I'm not read up enough on the subject to make an educated answer, but I'll look to Dr. Boudreau in case she has anything to add here.
No, that's exactly right. I would just say it's always a risk-benefit analysis, right? So if the physician is worried about potential spread, which, as Cassadie says, is a real thing, they may have said, we're less likely to identify something actionable than we are to introduce new mutations, and I can understand that perspective for sure.
And then Gary just popped into the chat and said, my wife had a Whipple in July 2020. When I asked the surgeon team here in Calgary about Know Your Tumor, they just looked at me and walked out of the ICU room.
Yes. So there definitely, I think I briefly touched on this, but probably skirted around it. There's definitely doctors who may not, and I think kind of to Dr. Boudreau's point, may not understand the benefits or don't feel that the benefits outweigh the risk of potentially testing. So I think definitely when it comes to that, it's definitely advocating for your wife, advocating for yourself if you're the patient, and asking to get a second opinion, asking to see a medical oncologist who may be able to talk to you about Know Your Tumor or other testing options. And actually I neglected to mention the subset, that 1,000 patients that didn't complete tumor testing through Know Your Tumor. Some of them, their doctors didn't believe in biomarker testing, and so they actually put their foot down. And we actually do have resources for those patients. I think Craig's Causes does as well, where you can find listings of specialists who specialize in pancreatic cancer. We can provide the same for the US. So definitely, absolutely encourage you to be an advocate for your loved one or for yourself, and reach out to an organization to get a list of specialists so that you can have that conversation with a doctor that may be more willing to talk through those risks and benefits of Know Your Tumor or biomarker testing with you.
It is, that's a common question that we get with, through these support for caregiver sessions, is that it's really hard. Lori and Sandy and I have talked about this, and actually we had a support for caregiver session on this that is pre-recorded as well. It's hard to be an advocate because there's always that fear of offending that person in the white coat, and what will the ramifications be if they make the doctor angry, and I'm not really sure how to get around that. It's hard. And I know that many caregivers and patients struggle with that, especially patients. And they can see the pre-recorded session on that session with Lori and Sandy, who talk about some of that advocacy and the walls that have been put up. But in the physician world, we know that many physicians, not many, but there's physicians out there that seem very opposed to change. or new things, or don't know enough about it. So they stick to what they know is the only way I can say that. And it is everyone's right to ask for that second opinion. And but I realize, emphasize that I understand that fear continues to be there even after you ask for that second opinion.
Thank you to Cassadie and Dr. Boudreau. That was great. Lots of great information, and the discussions